Okay, so where are we up to? Let me show a little bit. That's fine. Okay, so just before we took our short break, we just looked at that display removal video. We're going to move on, and we're going to start to look at some of the other components that are part of our Max display system. Okay, the lighting control modules. So we've got a lighting control module for the captain and first officer. They do the same thing. They're not the same component. Obviously, they are a mirror image of each other, as you can see on this picture, but they have the same controls. Mention the controls briefly, just a little bit earlier on. The main panel brightness control, excuse me, that is to do with the actual brightness of the instrument panel itself. Has no effect on the displays. The lower controls here, the outboard and inboard display units, the brightness and contrast controls. So as I said earlier, we have the means of controlling not only the brightness to these displays, but also the contrast to both of them. And obviously, as I said a moment ago, the reason for we have the contrast is because of the raster element to the weather radar and the enhanced ground proximity warning, the terrain information. Normally, we would only show the weather radar or the terrain information on the multifunction display, but if we have lost the multifunction display, then we can show nav data on our primary flight display. Okay, so again, we have the ability there to control that element, the contrast element. So we've got an inboard and outboard display unit control for both first officer and the captain. The PFD MFD switch up at the top here, this one, primary flight display, multifunction display. As it shows on the tin there, normally the switch is in the normal position. This allows for automatic switching of the displays. So if I lost an inboard display, if I lost, let's say, an outboard display, then the system would see that because of the health report that's going back to the display processor computer from those displays. The DPC would see that that display has failed, so it would automatically compact the inboard display. When I mean compact, if the captain had a full nav display on their multifunction display, then it would go into a narrow format, a compact mode. So the nav display would shrink to half the screen size, and the other half would then become the primary flight display. So we've maintained the visibility of the PFD for the captain. Okay, PFDs, primary flight displays, are essentially more important than a nav display. You don't always need a nav display, but you do need a primary flight display. You also have the option to move the image from the inboard display to the outboard display. Again, it's not something that would normally happen, but this allows what we call for manual reversion. If for whatever reason the automation fails, or in this case maintenance can use this switch to prove the logic, the switching logic within the system, I can force the display processor computer to display two images on one display. So in this case, if I move that switch to outboard, the inboard captain's display would be switched off, and you would see, let's say, a nav display and a PFD on the captain's side. Okay, auxiliary window goes across the top. If I have lost, let's say I'm flying around in the aircraft and it's in the normal position, and the first officer's inboard display should fail, then normally the engine display is defaulted to the first officer's inboard display. The engine display would automatically move across to the captain's side, okay, to maintain visibility of our engine information. But again, you can force it by using those rotary controls, what we call reversionary switches, manual reversion. So you've got the two switches there, one for the captain's side, one for the first officer's side. Okay. The instrument switching module, up on the P5 panel, no significant changes really. The source selector, again left in the auto position normally. And this is all to do with the display processor computers, okay? Nothing to do with the displays themselves, but the source of the information, where the displays are getting that information from. So as I said to you earlier, In the auto position, then DPC number 1 would normally provide an image on the captain's displays, and DPC number 2 would normally supply an image to the first officer's inboard and outboard displays. The logic is done automatically by that fibre fabric card within the DPCs themselves, but if, let's say, a graphics generator or a graphics card should fail, then the displays will automatically reconfigure themselves to maintain 4 images on 4 displays. If I lose a complete display processor computer, regardless of which one, it doesn't matter, they're both the same. If I lose a DPC, then I've lost all the graphics cards and graphics generators within that DPC. It's not a problem. The DPCs, as I've mentioned before, they have a crosstalk buzz. They know the health state of each other. They know what each other's capable and not capable of doing. So again, they will automatically reconfigure. And let's say DPC number 1 has failed, then DPC number 2 will automatically take over and provide an image to all 4 displays. That's the reason we have the 4 graphics generators in each of the display processor computers, okay, for redundancy. Again, it's automatic. It should work automatically. If it doesn't, we can force it. And we also can use this switch again, very similar to what we've used this reversionary switch here for. We can use this one to physically move, or so to say physically force the system onto DPC1 or DPC2. Again, what we call a manual reversion. Okay. Maintenance will also use this for testing the switching logic within the system. Okay. I'll show you the indications for that in a moment on the flight deck. Control panel. These display control panel switch. This is to do with the EFIS control panel. We don't have a standby EFIS control panel. We don't have a graphical representation of an EFIS control panel like we do on the 8.7 that we can turn to should we have a failure. What we have on the Macs is this 3-position switch. Again, left in the normal position normally. If I lose, let's say, the captain's EFIS control panel, that means the captain is no longer able to change information on his MFD. Okay, primarily on the MFD. That wouldn't be a good situation to be in, not being able to change the information that we want to show. So what we would do is we would move that switch, and you lift the switch and move it across, and it latches onto 2. When I do that, it connects the first officer's EFIS control panel to the to the captain's side. So when the first officer makes changes on their EFIS control panel, it will not only change the information shown on the first officer's side, but it will also change the information that's shown on the captain's side. Okay, again, allowing us that flexibility if I lost one of my EFIS control panels. With both of these switches, when we move them manually, there's no automation with the display control panel. It's purely a mechanical manual function to switch, okay, unlike the source, which can be automatic as well as manual. Regardless, though, we do have to show the crew for non-normal events, whether they be automatic or manual. So when it comes to the displays themselves, we will show that information on those displays, and I'll show you where it is shown to both the crew. This is our EFIS control panel, and I said to you earlier that it looks very similar to many EFIS control panels. It looks similar to the ones that are fitted to the NG. There are many options on the NG, so you may or may not have seen some of the controls are on these EFIS control panels. On the Macs, we have what we call a VSD switch. That stands for Vertical Situation Display. It's to do with our enhanced ground proximity warning system. It's to do with terrain information. Normally on our nav display, you will be looking down on the dot matrix pattern that the terrain provides for us to give you give the crew some kind of idea of the terrain that they're flying over or around, some tactile information type thing. With the VSD switch, it can either be on or off. It doesn't really matter. It's completely independent to this terrain switch down here, which would normally bring the terrain information on. The VSD switch gives you a side-on view of the terrain that you're potentially going to be flying over. Got a better picture of it coming up in a moment, and I'll explain that in more detail when we get to it. Minimums, again, pretty much standard radio or barometric for your minimums call out with a reset switch. Flight path vectors, FPV again, quite common these days. Meters, well, it doesn't actually change the display, the altitude display from feet to meters, it just displays both. So normally it will display feet. If you press the switch, it will show feet and the meters equivalent to that feet, the altitude. Down here, you've got your barometric controls for your barometric pressure, either in inches of mercury or hectopascals, whichever you use. And you've got a barometric control here that allows you to change that setting, okay? Manually change it. The standard button, well, again, depends on whether you're in inches of mercury or hectopascals. It's either 1025 or 29.25, 29.92, I beg your pardon, for inches of mercury or hectopascals. Down here is to do with indications for the nav displays, VOR or ADF. ADF is an option on the aircraft. ADF is an option in many countries now. However, if your aircraft flies in EASA airspace, and I believe in Russian airspace as well, it has to have an ADF fitted. I'm sure there are other regions around the world that still require ADF as mandatory. But certainly in my part of the world, EASA for the time being, until a few weeks' time. But I'm sure the CA will go down the same lines as the EASA. I can't see things changing too much on those things. So VOR, ADF. We've also got the switches down the bottom here for our weather radar, station idents, waypoints, airports, data information, position, and the terrain switch. Okay. These two switches here, these rotary controls here, again, very common, see them on pretty much every EFIS display, EFIS control panel. You've got your mode controls here for the information and how we're going to display that information on our nav displays. So approach, VOR, map and plan. Okay. We also have the center switch. There are many formats on these displays that allow me to change how we see that information, whether it's what we call an expanded view, where it's like a zoomed in view, about 120 degrees of a compass rose, or what we call a centered view, where it shows a complete 360 degree compass rose. Okay, information's the same, it's just shown in slightly a different way, possibly. Okay, so we can alternate between centered and expanded just by cycling that switch. The range selector, the traffic switch obviously in the middle is to do with our TCAS and showing traffic information on our displays. The range selector though is different to the one that's fitted to the end. Well, the EFIS panel, as I say, is different to the one fitted to the NG, and this is one of the reasons. On the NG, as far as memory serves, I haven't seen an NG without this, the actual range is stamped on the panel itself in nautical miles. On the Max, we don't do it that way. The range is not shown on the actual panel itself, it's shown on the nav display. Top left-hand corner, a little box, white box, inside there will show your range that you've got selected in nautical miles. Okay. So they're the EFIS control panels, one for the captain's side, one for the first officer's side. Okay, up on the glare shield, either side of the mode control panel. Still in the same position, but slightly different panel to what you're possibly used to. This is our multifunction panel. This is a new panel for the Max. It's down just forward of the main thrust levers between the two CDUs for the flight management computer. It's where the center screen used to be on the NG. And as its name would suggest, it's a panel that does a whole multitude of things. It's not just dedicated to one system on the aircraft. On the top right-hand corner, we're interested in this at the moment because it's to do with the Max display system. It's our MFD control panel. On here we have an engine switch, okay? And I'll go through these switches briefly now, and then I'll just give you a bit more information when we get to those pages. We have a system switch, an info or information switch, and a cancel recall switch. The cancel recall switch is an option, okay? You won't always see that. If you take the option of having a Cat 3B aircraft, then you'll have this cancel recall switch. It allows me to cancel and recall advisory messages for Cat3. Okay, cancel recall, those Cat3 messages, if you have the option, are shown on the engine page, and I'll show you where they are when we get to it. The engine transfer switch, that allows me to transfer the engine display from the first officer's inboard display to the captain's inboard display, normally. Okay, if I've lost an inboard display, or I've lost both inboard displays and I've only got the outboard displays, then that switch will alternate it between the outboard displays, okay, that engine display, okay, the PFDs, if it's in the compact mode. But normally we would only show engine information on either of the two MFDs, the inboard displays. Auto brakes, brake selector switches, anti-skid, warning lights, brake temperature, tyre pressures. Again, these are all to do with brakes and tyres, that type of thing. Brake pressure, fuel flow on here, again, nothing to do with our max display system. We also have these two selectors, one for the captain side, one for the first officer. Okay, the selectors look pretty much the same. They're labelled slightly different, okay, but they do the same job. Each of our selectors has a different cursor, or a different type of cursor. I mentioned earlier that the maintenance panel at the back on the P61, you've got the cursor selector on there, okay? That is idented left and right, either the captain's, which is the left inboard, or the first officer's, which is the right inboard display. And it puts that cursor, that maintenance cursor, on either of those two displays. It's a crossed wrench indication, okay, that the cursor will change to. Same colour, magenta, like these are, but it's a cross spanner, cross wrench sort of display. So this is the captain's cursor, and this is the first officer's cursor. When it comes to the displays themselves, we press this systems button, it will bring up a systems page. Okay, makes sense. It does exactly what it says on the tin. You press the system switch, you get a systems page. Where do we show the systems page? Well, that depends. That depends on where the engine page is currently being shown. If the engine's page is being shown on the first officer's MFD, the inboard display, then when I press that switch, it shows the it shows the systems page on the captain's inboard display. Okay. If I have a nav display on there, it puts it into the compact format, and now I've got two independent screens. Okay. If the engine display is on the captain's inboard already, then when I press the system switch, it goes to the first officer's side. Okay. So normally we just have what we call a single MFD. Okay. And you're not really going to be bothered with changing these switches over. Okay. These switches are idented left and center and right. Those switches have caused, or can cause, quite a lot of confusion. Okay. I was hoping to be able to bring up what we call micro SIM on my machine, on my laptop, but unfortunately my laptop that I used to have, a very powerful laptop, has died, basically. It's an old thing. It was good, it was powerful, but it's had its day. And now it's in my bag waiting to go back down to Gatwick when the government let me leave my home. So at the moment I've got another laptop that Boeing have kindly provided me, but it's not as powerful as I would like it to be. And unfortunately, even though I've tried, I can't show micro SIM and also use WebEx at the same time. The computer's just not powerful enough. For those of you who don't know, micro SIM is a little bit like a CBT, computer-based training system, and a desktop simulator. It's an extremely good tool to use, not only as a student, but also as an instructor. And as I always say, a picture speaks 1,000 words. Whereas if you can actually demonstrate something in a classroom, it makes life a lot easier for everyone, including the instructor. But these switches have caused some confusion, okay, in how they're idented, how they're labelled. So as I say, I would have liked to have shown you exactly what these switches do, but unfortunately I can't at the moment. These switches are primarily used when we have what we call dual MFD mode, okay, when the system goes into a dual MFD. I'll talk to you about the dual MFD mode when I get to that page, okay, and I'll do my best to explain it without being able to show you. So just keep that at the back of your mind for a moment, the left, center and right. The control switches themselves are just like the ones on the P61 panel. They do exactly the same function, 3 controls in one. The outer portion, is just a 2-position switch, either center and right, or left and center for the captain. The one in the center, this here, is a rotary switch, like a tabber. Every click, it moves the captain's or first officer's cursor, whichever you're using, to the next selectable area on that display. Okay, like a tab key on a computer. And the select button, again, just like on a mouse. When you press the mouse button to select something, when you press that select key, it makes that selection. Okay. So that's what those switches are for, and we will talk about those again a little bit later on. Okay, I will go through them a little bit later on with you. Again, another nice graphic, just showing you one of the display processor computers. As I say, they're both the same, fit in exactly the same location as they are on the NG. Completely different unit, not interchangeable. You cannot put these into an NG, and you can't put a DEU from an NG into a MAX. Okay, they're not compatible. The DPCs themselves are a lot larger than the DEUs on the NG. There's a lot of software inside here, huge amounts of software inside these display processor computers. We'll show you how to view that software inside the DPCs a little bit later on today. Okay, but I say they're the same part number, same location, cooled using the cooling air system for the electrical equipment bay cooling system. The air that comes out again goes over the optical smoke detector, as with everything else, as all the other exhaust from the bay, just to make sure that nothing is getting too hot or catching fire. They weigh about 10 kilos, something around about that nature. Okay, pin strap for location, cross talk between the two, so they know each other's capabilities, the health of each other. And as I say, if you want to display anything on any one of those 4 displays in the flight deck, then it has to go through here first. There's no direct input to any of the displays when it comes to images. It all has to go through these. Don't forget, again, always follow the AMM, always reference the AMM. It's your get out of jail free card. If you followed the procedures and something goes wrong, it's not your fault. Okay. Always remember to follow the AMM if you remove one of these DPCs. They will always have a power supply to them if the battery is physically connected. Okay, from the hot battery bus. Don't forget, it's for that power supply that it needs to run the calendar clock function. Okay, for those power interrupts and to shut the aircraft down. To shut the DPC down. So there's always power to these. Don't just pull them out, even if the aircraft's switched off. Okay. Make sure you follow the AMM, pull the relevant circuit breakers. Again, this is something that, I will now show you this video. Okay, he says. Let me just move that out of the way, get to my videos. So this has got audio to it. So what I have to do with this laptop, with my computer, is I'll have to unplug my microphone. I've turned the volume up on my computer to maximum. If you need it any louder, then you'll have to turn your volume up on your own computer or whatever you're viewing this or WebEx on. I will unplug my headset and I will let the video run. You've probably seen this before. If you sat on the differences class or the line and base course, you would definitely have seen this before. But it gives you an idea of the fiber optics, how to keep them clean, how to inspect them. Okay, as I say, fiber optics is good unless you start to disconnect things. If you do disconnect it, make sure you put the relevant caps on. Don't just leave them to the ambient air, else you'll have problems. Okay, so I'm just going to have to stop presenting while I open this, and then once it's open, I can start presenting again. Okay, so I'll just stop presenting for a second. I shall open this. This is the only way I can do it with this machine. If I do it any other way, then it falls out with me. Those are toys out of the pram. So that one there. I'll pause it. I shall bring you guys back on so you can see it. There we go. Hopefully you can see that now. And I will unplug my headset so you can hear what's being said. Okay, thank you for confirming. Appreciate it. If you need it any louder, then
You'll have to turn your own volume up on your laptops. This is as loud as my machine goes.
This video will demonstrate how to inspect and clean the 787 fiber optic cable interfaces in accordance with the Aircraft Maintenance Manual Task 2010-34. The cleanliness of the fiber optic cable interfaces is important. Dirty fiber optic cables may lead to possible system faults and failures. There are two steps in this process: inspecting and cleaning. First, visually inspect the cable ends using an inspection video scope. Remove the alignment sleeve insert if needed. Install the inspection video scope probe to the end face to be inspected. View the fiber optic cable end face on the video scope screen with the probe magnification set to 200 times power. The fiber optic cable end face is divided into 4 zones. Zone A is the core. Zone B is the cladding. Zone C is the epoxy bond line. And Zone D is the ceramic ferrule. To remove unwanted material, we will demonstrate the dry swab, wet swab, and cartridge pen cleaning methods. Gloves or cots are recommended to prevent further debris accumulation. For cleaning with a dry swab, use a rolling motion to brush the end face with the swab. Use each swab only once, then discard. Multiple uses of a swab could result in transferring debris or film to other cable ends. Inspect to verify cleanliness. If the end face is not clean, use the wet swab method. For cleaning using the wet swab, apply a small amount of solvent to the swab. Roll the wet swab on the end face to clean. If the end face is too wet, dry it using canned air or a dry swab. Verify cleanliness by inspecting with the scope. The next cleaning method is using the cartridge pen. Align the tip of the guide cap with the end of the cable. Then push the pen forward until it makes a click. Verify cleanliness by inspecting with the scope. Once clean, reinstall the alignment sleeve if it was removed. Then protect the clean end face by installing covers such as a dust cap or reconnect the connector. In this video, we have reviewed the steps necessary to inspect and clean the fiber optic cable end faces. Reference your aircraft maintenance manual for the proper procedures.
Okay. Thank you. So I'll just plug my headset back in.
Okay, so I hope you were able to hear that. As I say, cleanliness is really second to none with the fibre optics. It really is. Let me just move that up here. I beg your pardon. There we go. Yeah, it really is. The biggest problems I ever seen with fibre optic is when people have left a fibre optic plug. They've just left it out. They're the biggest problems that I've seen with fibre optic cables. Okay, right, let us move on. Just give me a second here for some reason. Hold on, there we go. And I want to bring that on. It's okay, it's fine. Okie dokie. Right. There we are. Put that Okay, so this is the primary flight display. Again, excuse me, not huge amounts of changes when you look at the information on the PFD itself. It's pretty much a standard what you would see on a normal regular PFD, primary flight display. If we start with this section at the beginning here, at the top, then again this is attitude information. So we've got information on here to do with our roll, our pitch, okay, our yaw. We also have the flight modes for the autopilot or flight director. Again, it's very similar to what you've got on the NG on many other aircraft. We try to keep this as similar as possible, so there's no huge amount of learning curve for the crew. Our speed tape down the left hand side here, our altitude tape. This is shown in feet. If I went to my EFIS control panel and pressed the meters switch, then it would on the top of here, it would show meters as well. So the equivalent in meters of whatever the altitude is showing in feet. Down the side here is my vertical speed tape. Okay, again, no huge surprises there. Our pitch information, roll information down here. This currently is land 3 that we're currently doing at the moment. We're in our localizer and glide slope mode, and the rollout and flare has been armed. Our source of information is showing ILS, so we're doing an instrument landing system. Okay, instrument landing is still the primary, the normal means of a coupled or manual approach to a runway on the MAX. However, the MAX does have the capability of the GPS landing system, or what we call GLS. Okay, GLS uses what we call a ground-based augmentation system to provide a virtual glide path from the aircraft to a precision point on a runway. It's an extremely reliable and an extremely accurate means of landing an aircraft. It doesn't require any real kind of information received from the ground, like a guidance information like you do with an ILS, localizer and glide slope information that you are actually receiving. All you're really connecting to is a ground-based augmentation system that provides you with error information to do with the current satellites that you are tracking for GPS. So it takes the error out of the satellites, what we call a VHF data link. When it comes to GLS indications, and I'll say I'm not sure how much you were told about this on the course, but when it comes to GLS indications, they are pretty much the same as ILS. Okay, you've got your deviation scales here for ILS, for your glide slope and your localizer. You've also got your deviation pointer. Okay, these are the scales and these are the pointers. Exactly the same with the GLS system. It's the same color, the same pointers, the same deviation pointers and scales. The only real difference is where you get that source of information from. Okay, the guidance source. So in this case, it's ILS because it's telling me here my source of information for guidance is ILS. If it was the GPS landing system, instead of it saying ILS on there, it would say GLS. Okay. The MAX uses a ground-based augmentation system similar to the 87. The 777X is using what they call a satellite augmentation-based system. It doesn't rely upon any ground technology at all, but four fixed point satellites. Again, another step. So the aircraft is capable of GPS landing if you have it, as well as ILS. GLS at the moment is only really authorized down to 200 feet. You'd have to disconnect at 200 feet right out and land it manually. So there's no coupled auto lands at the moment with GLS as you have with ILS, but it's only a question of time. Okay, as everything, it needs to be proven, and in time, GLS will become the standard. It's a better system all in all, and it's certainly a lot more low cost for airport authorities. A single ground-based augmentation system can cover maybe 15, 20 different runways, and if it's local to two airfields like here in the UK where you've got Heathrow and Gatwick in close proximity, you could put a ground-based augmentation transmitter between the two airfields and it'll cover both. So you don't need individual transmitters for glide slope, ILS, glide slope localizer at each end of the runway. You just have one system, that's it. So again, a lot cheaper all in all. So GLS, it is capable of GLS. Radio altitude, down here at the bottom, 700 feet rad alt, 2 rad alt systems on the aircraft, a left and right system. Again, options when it comes to radio altimeters. This is primarily where I've mostly seen rad alt information displayed, down the bottom here just above that localizer pointer. There is an option to have the rad alt information displayed up at the top right hand corner, and it's like a countdown circle that counts down with rad alt in it. But this is why I've primarily seen it. That is an option to have it up in the top right. If your airline or the aircraft you're working with, the airline, if they have their rad alt up here in the top right hand side, I would guess on the Max they'll have it there as well. This is what they class as a rising runway, and again this is optional. As the aircraft starts to descend below 200 feet radio altitude, then this green box starts to come up. It's basically showing you where your aircraft is relative to the runway itself, what they call a rising runway. Marker beacon, well again, you've still got a marker on this aircraft. Outer marker, middle marker, an inner marker on here. You also have back course as well. So again, it's shown in it's shown in exactly the same place as it is on most aircraft. Same colours, same tones, no difference there. Down the bottom, we've got what we call a mini map. The mini map is like a very small nav display. There's no on-off switch for this. If the system's capable of displaying the mini map, it will be displayed. It's always there as long as it's serviceable. And again on here, you've got your basic navigation stuff. You've got your aircraft here, your direction, course pointer. You've got, your heading pointer there. You've got your heading, your compass rose on here. And then you've got indications to do with, in this case, your ADF bearing pointer. ADF, as I say, it's a standard, it's an option on the Max. If you do have the ADF system fitted, then we give you the latest technology, the latest boxes. But ADF's still ADF at the end of the day. It's still not good. Okay, but I suppose it's better than nothing. It just points in the general direction of a non-directional beacon. We only ever used it really on night shift to listen to the radio and listen to the football scores on medium wave. Apart from that, we never really used it. You've also got your VOR course pointer here, and then this here is to do with heading. Your selected heading, should I say, that you've got selected on your mode control panel that you would use for your autopilot or your flight director. Okay, on that mode control panel. Down here, you've got information relating to VOR and ADF. No real information at all to do with the ADF. VOR number 1 or number 2, whichever you've got selected. This is the ident. This is pane field, PAE. When you initially tune a VOR, normally they're tuned automatically by the flight management computer, but you can manually tune the VORs. It will show you the frequency you've tuned, and then it will show the ident. DME stands for distance measuring equipment. It gives you the slant range to a beacon, a transmitter. Okay, it's they are actually interrogators. We interrogate these ground-based systems. Not all VORs have a DME. Many of them do, but not all. We call it a co-located DME system. So in this case, when you tune to a VOR, if it has a co-located DME system, it will automatically tune the DME for you. And the VOR will give you guidance. Okay, you can follow the guidance, select a radial, one of 360 degree radials, and then it will also show you the distance in slant range, okay, to that VOR in this case. Okay, ground speed, true airspeed. Again, this is information coming from your inertial reference system, and also flight management computer has an input in this as well. On the left-hand side, on the left-hand side here, let's get rid of that. On this left-hand side, you will have what we call an auxiliary window. Now, for those of you who've got 787 experience, it will look quite familiar. It's very similar information that's shown on here to do with the max. Up at the top here, this HGS capability. Again, HGS, head-up guidance system. That is an option. Okay, not all aircraft have that on it, but it is purely a sticker, a placard. Okay, so on a lot of aircraft that I've worked on in the past, it will give you the capability of the autopilot, or in this case, the head-up guidance system, Cat 3, Cat 2, Cat 1, or if it's US, if it's not available. Normally on aircraft, that is a placard, a sticker that you can change depending on the capability, the current capability of that system. On this aircraft, we don't have a sticker; it's just a digital placard. So we can change this, and I'll show you where to go to change that. Maintenance will change it depending on the current capability, or in this case, of your head-up guidance system or of your autopilot. Okay, it is purely an indication. It has nothing to do with failures of the autopilot. So if you lost capability and the autopilot dropped from Cat 3 to Cat 2, it wouldn't automatically change. Okay, you'd see Land 2, let's say, on your primary flight display here, but this would not necessarily change. Well, it wouldn't change until maintenance changed it. Flight number is shown on here. Your transponder code. Again, when you change your squawk code on your ATC control panel, not only will you see the squawk code on that control panel, you'll also see your current squawk code on the auxiliary windows for both sides, captains and first officers. SELCAL, selective calling. Again, it shows you the aircraft code. Aircraft have their own individual codes for selective calling. So it shows you the current code that's on the aircraft. Tail numbers, again, going to change with the aircraft, whichever aircraft you're on. It's going to have a different tail number. Down here, you've got UTC time, date, and elapsed time. So the time and date is coming from the GPS, the Global Positioning System, okay, the satellite network. That information that comes from the GPS goes to the display processor computers, and the display processor computer puts it onto this auxiliary window so you can see it. Elapsed time, that is weight off, weight on wheels, flight time. Okay. This here is like a stopwatch, a chronograph clock. You've got a switch on your glare shield. It says clock, believe it or not. When you press the switch, it starts the clock. The clock starts to tick round. The analog clock here will start to tick, and the digital readout will start to move as well, count up. Press that switch a second time, it stops the clock. Okay. Press it a third time, it resets the clock, removes the clock. Okay. So you've got a chronograph clock there. You've got all of this on the captain's side and on the first officer's side. Okay, on the first officer's auxiliary window. This here is showing you an example of what you may see on the first officer's side. Not what you will always see, but what you may see. It depends again on the head-up guidance system, the head-up display. If you have a head-up display fitted to the MAX, then the head-up display combiner and projector are fitting to the captain's side. So the captain will be using the head-up display to fly the aircraft. Captain will be looking directly through the combiner, through the windscreen and outside. The combiner pretty much shows you everything that's on your primary flight display. Okay, saves the crew having to constantly look up and down. They can look straight through it. Because the captain is flying the aircraft using the head-up display system, then it's the first officer's role to monitor the status of that head-up display system. So only on the first officer's side will he have this window. Okay, it's just a graphic. That's all it is. And it's above, it's in this portion here on the first officer's side. And on there it shows the current capability of your head-up guidance system. Okay, so the captain's flying using the head-up guidance system, the displays. First officer is monitoring the ability of that head-up system, how capable it is, any failures and such like. Okay, it's like a status and alert window. So that's the PFD. The next ones we're going to look at are to do with our nav display. And again, for most of you, you've probably seen these before. A nav display really is a nav display. There's not much you can do with it that we haven't already done with it. It's it's just on a different display unit, okay, in the case of the Macs. You might have a little bit of additional information on here that you've not had the capability of before, but they're pretty much the same. In this case, I've got my nav display showing on my multifunction display, either the captains or first officers or on both sides. I've selected the approach format. It's very simple to do. You move this rotary control here to APP, and it will show you this format, the approach format. This is in the expanded mode, or the full screen mode, where it's taking up the entire MFD, and this is in the half screen mode. Okay, the half screen mode is when it's taking up the half of the MFD. You possibly got next to this an engine display, or you may have a maintenance display, okay? But it's taking up half of that screen. Excuse me, beg your pardon. On here you've got basic information, you've got your compass rose, okay? Because it is the approach, we've got ILS information on here. You could see GLS information on here. And again, the only significant difference is the source. So up here where it says ILS1, it would say GLS1. Everything else is the same, okay? Again, you've got your deviation scales for your localizer and your deviation scales and pointer for your glide slope, okay? And our localizer, which is giving us the center line of the runway, our glide slope is giving you the correct glide path, normally about 3-degree descent to a runway normally. And together they give us our glide path, okay? The GLS system gives you exactly the same information. It's just getting that information from a different source, okay? And again, as you start to line up onto the runway, then this bar will start to come more centralized. This pointer here, that's normally selected to the course of the runway. So on your mode control panel, you would have selected as part of their checklist for landing, they would have selected the actual course that the runway they're going to land on, the heading of the runway they're going to land on. So as this starts to move in, this will also start to turn because we're making our approach. We're going to intersect the localizer, okay? The glide slope works in exactly the same way. As we intercept that beam, that glide slope beam, it becomes centralized. So as we come onto that beam, we hit it, and then we follow the beam down. Okay, the guidance down. We always fly towards the pointer. So on this aircraft, as I say, you've got the option for GLS as well, but the indications are the same. Okay, ILS can either be done manually, fly it manually, following the beams, the pointers, or it can be done as a coupled approach. So the autopilot, if you have the Cat 3 capability, then it can do a full auto land. Okay, it is capable of a full auto land. Same information shown on here, just a smaller format. Okay, we've compacted the displays. Up at the top here, again, significant difference to the NG. You've got your range in a white box. Okay, on the NG, it's normally stamped on the control panel here. On the Macs, it's always shown on the display. And that is the range that you've currently got selected and the range that you can see on the nav display. This is my aircraft here. This is 40 nautical miles at this point. Okay, this is our half range here, which is 20 nautical miles. So that display there from our aircraft to this point here is 40 nautical miles. The aircraft stays stationary and the map moves around the aircraft. Okay, the map moves around the aircraft. Again, we've got ILS selected, so we've got the ident for the ILS, we've got the DME, and we've got the course that we've got selected on here, 111 degrees. Okay. So again, ILS don't always have distance measuring equipment. If they do, it's automatically tuned when you tune the ILS. All this here is to do with ground speed, indicated airspeed, and also to do with wind direction and wind strength. Okay. Again, pretty much standard on most modern aircraft these days. This next picture is to do with VOR. Okay, VHF omnidirectional ranging. I always explain a VOR system is a transmitter physically based on the ground, and you tune to a VOR. When you tune to a VOR, you can then tune to a radial. A radial is like a spoke on a bicycle wheel. There are 360 spokes on a VOR, 360 radials. Okay, you can select any one. You can tune the system to any one of those radials by changing your selector, okay, your course selector. As you change that selector for your VOR, then the actual pointer itself, the bearing pointer, will start to turn to point towards the VOR and also to that actual radial you've got selected. And then as you fly towards the VOR and you intersect the radial, then as you fly towards it, in this case, this is my aircraft here, we're flying towards the VOR. The VOR is over here somewhere, okay? As I fly towards it and I go through this radial here, as I get towards it, this deviation pointer will start to come centralized. As it comes centralized, if I'm flying the aircraft manually, then I will turn it. When in this case now, the whole display will be this way around, so 180 degrees would be up here. This would all be aligned. And that means I'm flying the 180 degree radial, in this case, to the VOR. As I overfly the VOR, this will go to say, and it'll change from to from. Okay, I'm flying away from it. Okay. Down here we've got two VORs on the aircraft, VOR number 1 and number 2. Down here we've got both of them tuned. Again, they're normally tuned automatically by the flight management computer. It will use VORs to triangulate the position for the flight plan, and the system will automatically tune to the best VORs to give a position fix. So on here we've got VOR 1, VOR 2, Seattle, okay, and Payne Field, and they both got co-located DME transmitters. So again, we can see the range there in slant range in nautical miles. Okay. The bearing pointers. This is the number 1 bearing pointer. It's what we call a single stroke bearing pointer. VOR information is always shown in green, and this is a dual stroke indicator for the number 2 system. Okay, shown up there. Same information on the half screen. So again, we've compacted the displays, but I've also pressed the center button here on my EFIS control panel. When I press the center button, it changes the display from what would have been similar to this, where you've got that compass rose going across the top there, about 120 degrees. It changes it to a full compass rose. If I press the center button again, it will change it back to that expanded mode. Okay. So that's our VOR and our display. The map, well, this is quite a busy picture that I'm showing you here. I've moved the switch to map on there. Map does exactly what it says on the tin. It draws you a map pretty much, and you can see your flight plan if you've got one. It gives you a head-down view, of like a bit of like a plan view of the area that you're flying around. In this case, we've got terrain also selected. So they've selected this button here. It doesn't turn the terrain on and off. It just turns the display on and off. Okay, so you're just either displaying it or removing that display whenever you cycle that switch. You've also got on the Macs this VSD button, which stands for Vertical Situation Display. And this button basically cycles this portion down here. If I press that button now, it would switch this off, and it would give me the normal terrain display for all of the nav display. When I press that button, you lose some of the nav display, and it's replaced with this VSD, Vertical Situation Display. Information shown in here corresponds to information shown on your nav display. Okay, just to give you an idea what's going on this display here, anything in magenta is normally derived from the flight management computer. So this would be our flight plan that we've got entered into our FMC CDU. Okay, and we're probably currently flying it either manually or automatically using the LNAV and VNAV of our autopilot. This is my aircraft. So again, the aircraft is stationary, and the map and the information moves around the aircraft. Okay. We're flying towards our waypoints. Waypoints are little stars. You can just about make out the white star there. Okay. There's a little magenta star. That's my active waypoint, the one I'm currently flying to. If the autopilot's engaged, when I get to that waypoint or close to it, the autopilot will start to bank and turn towards my next waypoint. If this is my next waypoint here, that will go magenta. This one will go white. Okay, now I'm flying to my new active waypoint. However, in this case, we can also see these cyan dashed lines. Those cyan dashed lines are significant on this aircraft because the information or the terrain that's within those cyan dashed lines is what's shown on the VSD. Okay, so in fact, looking at this, I know that I am not flying the aircraft either by flight director or autopilot using LNAV and VNAV. Okay, so I'm probably flying it manually, or I'm flying heading or something of that nature. If I had LNAV and VNAV selected as flight data, as an autopilot or flight director mode, then these cyan dashed lines would not necessarily go straight out. The cyan dashed lines would follow my flight plan. Okay, so this point over here, which is this point up here at the moment, this point up down over here would potentially be this point over here if I had LNAV and VNAV selected, because these cyan dashed lines would now come this way. So it's not necessarily what's the terrain that's directly in front of my aircraft, it's the terrain that I'm potentially going to fly over as part of my flight plan. Okay, an excellent piece of equipment, I reckon. I think the enhanced ground proximity warning system in itself, the terrain warning, has saved countless lives over the year, countless aircraft, and I think having a vertical situation display as well now provides even more information to the crew, visual awareness of the terrain they're potentially going to be flying over or in between. Okay, many years ago, when I was a youth, which was many years ago now, I was doing some TCAS, provisional TCAS mods for some aircraft in Bhutan in the Himalayas, in Paro, and that airfield there is about 8,000 feet. To get to it, you are flying around the Himalayas. Most of the crew for the airline were ex-military pilots, Indian Air Force or Royal Air Force, most of them, and on the approach to the airfield from about 10-15 miles out, pretty much all the terrain was above you. You were looking up at the mountains as you were flying through. As soon as you took off from the airfield, depending on which direction you were going, you instantly got a terrain warning, a pull-up warning, because you had a 16,000, 15,000 feet mountain right in front of the runway. So it's one of the most interesting airfields I've ever flown into. But terrain information obviously is pretty much all red at that point. As you can see here, different colours determine the distance that terrain is below your aircraft. It's all relevant to your current altitude. The closer you are to it, the brighter the colour, red being the closest. So red anything in a dot matrix in red is at least 2,000 feet above you. Okay, but apart from that, the EGPWS is pretty much the same as it is on any other modern day aircraft. Saved countless lives again over the years. What they call CFIT, controlled flight into terrain. It saved a lot of those incidents over the years. I'm sure you probably get quite a few of those up around the Seattle area with all those mountains around there, as well as other countries, mountainous terrain. Okay, we'll just have a look at this and then we'll have another break, guys. So our flight plan. So it is a requirement that the crew have the ability to view an entire flight plan. It hasn't always been that way, but recently, well, not that recently now, I guess, time goes so quickly, but we now have to have the ability for the crew to see their complete flight plan. So we've moved this control switch here, this mode switch to plan, and this is going to now allow the crew to see an entire flight plan, whether they've entered it manually or whether they've chosen a flight plan that's already loaded into the flight manager computer that the airline flies most days. These, again, it's slightly different to these other displays that we've seen. A few changes. One of the changes that you will see straight away is that the actual map stays centralized. Okay, the map doesn't move around the aircraft. The aircraft moves around the map. Okay, so here we've got our flight plan. These are our waypoints, which are points, fixed points. They may be ground-based, a fixed point on the ground, but more often than not, they're just a virtual point in space that we fly to. In this case, this is our active waypoint. It's in magenta, so I'm currently flying towards this one. This will be my next waypoint. So as I get to this one, the aircraft, if it's automatic, if the autopilot's flying it, the aircraft will start to bank at this point. This will go white. This one will go magenta. The aircraft will move up, and then the map will start to move down to centralize everything again. Okay. The other changes on this compared to the other displays is that this is always oriented towards north. Okay. So as I say, it will always point that direction. The map will not move. The range is shown in exactly the same places on the other displays, but the range on the display itself is shown slightly different. On the other displays that I showed you earlier, it's in this case 20 nautical miles. This is my aircraft, 10 and 20 nautical miles. So it's all in front of me. On this display, on this display, 0 is in the center. I have 20 nautical miles in front and 20 nautical miles behind me. That's why it says 40 in that display here. The range itself is 40, what the display is showing. However, the halfway point is 0 in this case. And then you've got the other compass points, north, east, south and west. Never eat shredded wheat. That's how I learned it at school. Okay. So that's the plan mode. Again, this is full screen or half screen compact mode. Again, you've got those options. Okay. The last display we'll look at, promise you, and we'll have a coffee break, is our engine display. Excuse me. So I'm not going to go into huge amounts of detail on this display. I'm going to let Brian do that tomorrow. I'm not going to steal his thunder. Okay. But on here we've got our engine information, amongst other things. All of our engine information is shown down the side here. We've got our primary engine information and also secondary engine information. Okay, so primary N1, EGT and fuel flow, if memory serves, and then everything else on here is secondary. The engine indication, or the engine display should I say, is normally shown either on the captain's or first officer's inboard displays, the MFDs. Never normally shown on the PFD, the outboard displays, unless we've lost one of our MFDs, okay, and we've compacted the displays. So this is all information relating to our engine, pressures, temperatures and such like, vibration. The crew messages, the crew alert messages, again, very similar to what you had on the NG, but all of these are just a graphic representation of an annunciator, okay? But you've got similar information on here. And again, I'm not an engines guy. I'm not even going to try to explain this. I'm going to leave that to Brian. He knows the engine better than I'll ever know it. Down here, though, we've got the Cat 3B messages, the cautionary messages. These are optional. If you don't have the Cat 3B system, you don't have the messages, you don't have the cancel recall switch on your multifunction panel, on your MFD control panel. Okay, so this is where you would see all of your cautionary messages for your Cat 3B system. And then down here, we've got message information for ATC and ACARS. Again, some of this will be optional, whether or not you've got ACARS fitted or not. This indicator here is your flap indicator. The mechanical analog type of flap indicator you had on the NG has been removed and it's been replaced with a graphic. Does exactly the same thing as the one on the NG. It looks exactly the same, it works exactly the same as in indications, where you've got your different flap settings here and you've got your pointers. Normally you should only really see the left pointer unless you get a symmetry breaking or something of that nature where you'll see the pointers break out, but you should normally only ever see the left. The indicator is always shown, so even when the flaps are fully retracted, we don't remove the display. I know that could be a little bit different to what some people are used to, certainly with 8.7, okay? But we always show the flap indicator. And then down below the flaps here, again, Brian will talk about this in more detail in these indicators here when he covers flight controls later tomorrow. But again, we've got some icons, some annunciators here. Again, it's just a graphic. Lean edge flaps when they're in transit, when they're extended, and load relief, okay, to protect the airframe. Down here, we've got fuel flow information shown in analog, okay, even though it is a digital system, we call it an analog display because we've got the three indicators as you would like of an analog instrument showing the center, left and right fuel tanks. There is an option to have a digital display where it's just a rectangle type of thing with fuel quantity inside it. Again, optional, Okay. The two different types of displays, analog or digital, you'll always have fuel information on this page. That isn't optional. That's standard. Okay, so I'm not going to talk anything else about that display. I'm going to let Brian talk about the relevant information to do with engines and such like when he gets to it. All I wanted to just show you tell you was where that display is shown and basically what you've got on there. Okay. So I think we'll have a coffee break if everyone's okay with that. Like I say, I'm not going to call the hour because we're all on different hours, but it's just gone 22. So in the UK, it's just coming up to 20 to 3 in the afternoon. So let's say come back at 5 to the hour. Okay, go and grab yourselves a cup of coffee, have a cigarette break, go for a quick jog round the block, get yourself some air, wake the person up next to you, and then we'll carry on at about 5 to the hour. Okay, I'll put my email address up on the screen again. If you do have any questions, again, just please ask. If you prefer to ask me via email, then ping me an email by all means. Okay.